Okay, so the problem I found most difficult to answer was find the velocity of the mass expressed as a vector in component form at a time t equals delta t, where delta t can be treated as a small single time step. So in order to solve this, first you need to use the momentum equation, which is delta change in momentum p equals F net delta t. And from this equation, you get the equation P final equals P initial plus F net delta t. And you can simplify this further to m times v final equals, because mv is momentum, equals m times your v initial, which is 0, negative v initial 0. That's your initial momentum that it gives you in the problem. Plus F net change in t. And so F net. In order to get this, we are going to use the previous problem, part A of this problem. And F net is going to be a combination of F spring and F net, or F gravity, sorry. Those are both vectors. And so these I'm not going to solve for because that problem was earlier, but the values of these were negative ks times so plus lo minus lo times y hat, and this one was 0, negative mg 0. So you get these two, and to get F net, you add them together. So then you get F net equals 0, negative mg plus ks, s, and o, 0. And no units. And so then you plug that into your equation, you plug it back into this equation, and you get mv final equals m times 0, negative v initial 0, which is what we had up there. And then you plug in F net here, so you get 0, negative mg plus ks, so, 0 times delta t. And your delta t, we're leaving as delta t for the whole problem, so you don't have to worry about that. So then if you go and reduce this further, or start simplifying stuff, you get mv final equals 0. Oh yeah, these should all be like this because they are vectors. Negative mv initial 0 plus 0 delta t times negative mg plus ks times so, 0. So now you add these together, which gets a little complicated. And so you have mv final equals 0, and then negative mg plus ks so, all of this times delta t minus mv initial 0. So then, to get your final velocity, your v final equals, you have to divide everything by mass because that is the way to do it. And so you get 0 negative mg plus ks times SO, all of this times delta T over M, and then minus the initial, because you're dividing this one by n, so those cancel out. Then you get 0 again, and again, no units. I got many points off because of units. No units because they're symbols, and since there's just symbols, you don't have to include units. And this is your final answer.